Okay, hi everyone. So we've been working on this problem, trying to prove that vertical lines go to circles. Well, when there's a problem that you can't solve, some useless advice, some terrible advice would be, try again. Okay, so let's get better advice than that. Here's some useful advice. Find an easier problem. I cannot emphasize how helpful this is. This is what I do whenever I'm doing math research, whenever I'm trying to prove something, whenever I'm trying to discover something or figure out how something works. So as an example, in this problem, you're trying to prove that every vertical line becomes some circle. So instead of doing, you're trying to prove that every vertical line becomes a circle. Here's an easier problem. The vertical line with a equals 2, in other words, this line, the line given by parameterization 2 comma t. In other words, if I wrote this as a complex number, 2 plus ti. But writing it as r2 is much easier. Anyway, so this gives a vertical line. It gives, namely, the purple vertical line right there. Okay. We want to get first, what's the equation, the parametric equation of this curve? Well, now we had that function that took a complex number z and sent it to 1 over 1 minus z. Okay. But, so what we really want to do is get some formula, comma, some formula, because that will allow us to plot this curve, and we remember that the complex numbers is just a two-dimensional real plane. So all we have to do is just plug in z equals 2 plus ti and figure out what is the real part and what is the imaginary part. That will give us a component function in a second. And this is an easier problem because we're not doing it for every vertical line, we're just doing it for a specific vertical line. So I'll sort of work that through for you. And then for that specific vertical line, once we actually go into the computer and we see, oh, we got this little circle correctly, then just don't try to prove everything is a circle. Just try to look at this purple thing and try to prove that it's a circle. Its center is experimentally this point. Later this will have to be in terms of a, but that's harder. So do an easier problem right now. Just prove that this is a circle. Okay. For example, is this distance always constant? When you have formulas, now let's get the formulas for that circle. The formulas are here. What are they? Okay, 1 over 1 minus 2 plus ti is 1 over negative 1 plus ti. And you can't see the real and imaginary parts here because of this silly division sign. So we learned a way to get rid of that. We do the complex conjugate. Okay, multiply both sides by this. And now down here will be a real number. Up here we'll have a real part and an imaginary part. And real divided by that real number and imaginary divided by that imaginary number are exactly these two formulas, just in terms of the real parameter t. So let's see how that works. First of all, the top is clearly going to be negative 1 plus I times minus t. And so we just need to see, like, what's the denominator here, what's the denominator here, and this piece is the second one, and this piece is the first component function. And so this denominator is negative 1 times negative 1, negative 1 ti and plus ti will cancel. That was the whole point of doing this. Ti and minus ti will be minus I squared, which is plus t squared. In other words, we're going to send t to the coordinates -1 over 1 plus t squared, comma, negative t over 1 plus t squared. Okay, and then you need to prove that these coordinates always have distance equal something, some fixed constant, from, well, looks like that's the center from -1/2, which is really -1/2 plus 0i. In other words, the point -1/2 comma 0. Good luck. Find an easier problem whenever you are stuck. Find an easier problem. And remember, math classes, math research, math sort of everything, whenever you don't know the solution, you're not just trying to understand some concept, but you really have to solve a problem, then, in my opinion, in my experience, the feeling is that of complete confusion and then stubbornly refusing to quit. Okay? And breaks are allowed and in fact encouraged and will help you. So do 30 minutes of confusion, then take a nap. And then do 30 minutes more of confusion, and then eat a snack. And then do 30 minutes more of confusion, and then go to bed for the night. Sleep, 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 sleep. Wake up the next day, 30 minutes of confusion, and then get a snack, and then 30 minutes of confusion. Okay, that's what math is. So if you like math classes, you'll learn to like repeated confusion followed by snacks and sleep.